All right, welcome to 9.2, more identities, more fun. All right, so 9.2 and 9.3 are kind of like 9.1 really. It's just learning more tools, more formulas, more ways to go from A to B. And now we're not really using these for anything interesting just yet. It's kind of like learning algebra, right? Learning algebra, learning how to move things around. You're not really doing anything useful yet, but they're the tools that are the foundations for more complicated things that we're doing in the future. So I want to say this is going to be a super interesting section, but really it's just kind of like we're working out our mathematical muscles and learning how to do a couple things. All right. So let's get to it. We're going to start with the cosine sum and difference identities. And again, these are all found in your identity sheet. But you can write it down here as well if you would like. And what you're going to get is that the cosine, you're not going to get it if you write it like that. What you're going to get is that the cosine of some angle alpha plus a different angle beta. Let's do two formulas at once. So I'm going to write plus or minus here. We'll get to what I mean by that in a second. Equals the cosine of the first angle times the cosine of the second angle, beta, minus or plus the sine of the first angle times the sine of the second angle. Now, many people probably haven't seen this before, but what I'm using these signs for, right? Plus or minus, you've seen plus or minus, and minus plus, you haven't seen. This just means that I'm writing two formulas at once, right? There's one formula with the top stuff and one formula with the bottom stuff, okay? So this is just shorthand. This is just shorthand for two formulas. And it just means that this sign up here has to be the opposite of what this is. So angle sum, we'll have this be a minus. Angle difference, we'll have this be a plus. So we choose both things on the top or both things on the bottom. Hopefully an example will make this a little bit more clear, but we're just writing two formulas at the same time. Okay. And we're not going to do I thought about it. I don't actually want to do a big proof here because it's just a lot of algebra, which I don't find super useful. But if you want like a sketch of the proof, I keep on switching. Like you could actually do this proof on your own. Not too bad. But if you're curious what the proof looks like, basically we just look at two angles. Let's look at some angle alpha and beta. And specifically, let's have these be both on the unit circle. So let's have them be the same length. So let's have this thing on the bottom. Let's call this angle beta. And let's have this bigger angle over here. Again, it's the angle that goes all the way to the positive x-axis. It's the whole thing, not just the difference. This is going to be the bigger angle, alpha. It doesn't matter which one's bigger or not. Now, both of these lie on the unit circle, right? We can think about them as points on a unit circle, and there's going to be a red point here. We know how to find the coordinates of this, right? We learned that the x-coordinate of an x-coordinate of a point on the unit circle is the cosine of that angle. So this red point here is just the cosine of alpha times, comma, the sine of alpha. And similarly, we could do the same thing here, right? This is the cosine of beta, comma, sine of beta. They're both on the unit circle. And so one of the things that we're going to look at is the distance between these 2 points. And the reason why is because there's another figure as well. What if we just kind of rotate? Look at the red lines. What if we just kind of rotate that a little bit? Because notice that this angle here is just alpha minus beta. This blue angle is alpha minus beta, so that's going to be something useful. We could also graph alpha minus beta ourselves and say alpha minus beta is maybe something like this. Let's look at a third angle. It's getting a little cluttered here. Let's have this third angle be alpha minus beta. So again, there's a point right here. This is the cosine of that angle, alpha minus beta, comma the sine of that angle, alpha minus beta. All right, and you can look at one more point on the unit circle. What's this point on the unit circle? It's the point 1 comma 0. All right, so basically, again, this is the cosine of alpha minus beta. This is sine of alpha minus beta. You really could just by yourself right now use the distance formula between the two blue points and the two red points. All right, and that's exactly what the proof is. Distance formula between the two blue points and the two red points. Because what's the difference between those two different distances? Well, notice that the blue lines, right? The blue lines are just the red lines rotated. They're the same shapes, just moved around a little bit. So if we use the distance formula, the distance between blue and blue should be the same as the distance between red and red. And so notice that the distance formula for the blue stuff is going to have cosine of alpha minus beta in it. And similarly, it's going to translate into the distance formula with the red points, which are going to have these ones. So it would be a fun little exercise. Just use the distance formula, use these points, set them equal to each other. That's where these identities come from. Well, that's where the subtraction one comes from. The plus one comes from basically doing the same picture, just adding the angles together instead of subtracting. Very, very similar. Okay, so cool stuff here, but it's just going to be a lot of algebra, a lot of steps, but this is how you could get started. Let's do some examples. Let's use these. Example 1. Find the exact value. Find the exact value of, part A, the cosine of 5 pi over 4 minus pi over 6. And now you may be tempted to just combine these. Don't do it, but you may be tempted. Say, okay, we multiply, get a least common denominator of 12, right? That's going to be multiply the first one by 3. Going to be 15 pi over 12 minus multiply this one by 2 pi over 12. It's 13 pi over 12. You may want to do this, but the problem is we don't know how to find the cosine of this angle exactly. So this form that it's written in is actually the nicer form because we know how to find the cosine of this exactly, and we know how to find the cosine of this exactly. Notice, by the way, that this is not equal to the cosine of 5 pi over 6 minus the cosine. This is not the way. Why is it not the way? Because I just told you over here, what if we box this in a golden box? I told you over here exactly how the cosine of some angle minus the cosine of another angle works. It's more complicated. You can't just subtract the two cosines. The word we use to describe that is cosine is not linear. Okay? So things that are linear work in this fashion. This is not linear, so we can't do this. We have to actually use the formula. So what we're going to do is we're going to use the formula, and it can help to say, well, this is our alpha, and this is our beta. The formula says it's going to be, all right, so this is two formulas in one, right? The gold box, two formulas in one. Which one are we using? We're using the difference. We're using the formula for subtraction. So we look at only the things on the bottom. Cosine of alpha minus b is blah, blah, blah with a plus. We look at the ones on the bottom. So we're going to have addition here. Going to be cosine of the first angle times cosine of the second angle plus the sine of the first angle times the sine of the second angle. And again, now we can just, this is an optional intermediate step, but it's usually a good idea. What is the first angle? It was 5 pi over 4. What is the second angle? Pi over 6. First angle, 5 pi over 4. And second angle, pi over 6. Now all that's left is to evaluate these directly with the stuff that we learned in the two previous sections, chapter 7. All right. So not two previous sections, two previous chapters. And now we just evaluate. So we'll use our triangles. We'll use what we know about where angles are positive and where angles are negative. We'll have one more thing in this next step, but really we're going to have to go off to the side and do some trigonometrizing. We're going to have to do some trig. All right. So let's get these two pictures. Pi over 6 is the easier one. Let's start with the easier one. Pi over 6 is 30 degrees. We have a triangle for that. Special 30, 60, 90 triangle where the short side is half of the hypotenuse. The long side is the square root of 3 times the short side. So the cosine of pi over 6 is a cosine of 30 degrees, root 3 over 2. SOHCAHTOA. All right, so that's what we'll do for that one. So we have something times root 3 over 2 plus something else times the sine of 30 degrees, which is 1/2. And now we just need to figure out these two. All right, so we already did these two. Let's figure out the other two. That's going to be a little bit more complicated. Let's draw a picture. Where is 5 pi over 4? Well, it's a little bit more than 4 pi over 4. 4 pi over 4 is just pi. Pi is here. So we're a little bit more than pi. Specifically, we're pi over 4 more. Pi over 4 is 45 degrees. So we go pi plus another pi over 4. And we get a reference angle of pi over 4, which is going to give us a triangle that looks like this. So if this side is -1 and this side is -1, this side will be the square root of 2 in coordinates. And you can write it like this, or you can use the positive versions. And remember that all squids train camels, or whatever way you want to remember this. And remember that sine and cosine are both going to be negative in this quadrant, but tangent will be positive. I forgot my head blocks stuff. Okay, so what is the sine of that angle? Well, let's start with the cosine, right? Cosine of that angle is -1 over root 2. And what's the sine of that angle? It's also -1 over root 2. All right, so that's what our angle difference formula has become. Now we just need to simplify. So this first one becomes -√3 over 2 root 2. Second one becomes -1 over 2 root 2. We can combine this. Let's factor a negative out from both of them. -√3 over 2 root 2 plus 1 over 2 root 2. They have the same denominator. You can only add or subtract fractions if they have the same denominator, but these do. There's just going to be -√3 plus 1 over 2 root 2. And the top cannot be simplified at all. And this is our final answer. Now we should be able to check our answer, right? This should be the cosine of 13 pi over 12. Well, what is the cosine of 13 pi over 12? We'll go to Desmos. We'll hit the little wrench icon on the side. Make sure that we're in radians. We're using radians. Close that wrench icon. What is the cosine of, I already forgot it, the cosine of 13 pi over 12? It's about -0.97. Now, is that the same thing that we got? Negative square root of 3 plus 1 divided by 2 root 2. Oh, they're matching up. So you can use a calculator to get an approximation of the cosine, but this is the simplified exact answer. So you wonder, where does this number come from? This is an approximation. Even though it has a lot of decimals, it's still an approximation. This is the exact answer, which looks a little wacky. You're wondering if you're wondering why 13 pi over 12 is not usually listed on a unit circle, it's because we don't want to write this on the unit circle. It's not super nice. So we just remember the 30, 60, 90 triangles and 45, 45, 90 triangles for our unit circles usually. But you could put this on the unit circle. Yeah, 13 pi over 12 has a cosine, an x coordinate on the unit circle of this. Okay, I think we're pretty much done. Well, I want to introduce the next problem a little bit. We're not going to do it all the way through. Where's my pen? It did not roll off the desk. All right, so part B, I'll start it. You can finish it on your own, but it's going to be exactly the same once we do the first step. Find the exact value of cosine of 75 degrees. So I say this is basically the same, but now we need to do this step. Now we need to do the green step in the opposite direction. We need to write this as the sum or difference of two angles that we know. This will be the cosine of something, and then either plus something else or minus something else. So we need to rewrite it. So my first thought is saying, okay, 70 degrees is 60 degrees plus 15 degrees. But this is not helpful because we don't know anything about 15 degrees. Sure, we know things about sine and cosine of 60 degrees, but 15 degrees is not one of our angles on the unit circle that we usually write and memorize. So we're going to have to choose another pair. And you could choose, write it as 45 degrees plus 30 degrees. Those are two angles that we know. I think there's some subtraction ones that you could do as well. 90 minus 15 also doesn't work. We could do like 135 degrees minus 60 degrees, I think. Yeah, that works. And notice that both of these add up to 75. So both of these are good choices. That's nice. Spell that word, Jason. Nice try. Both of these are good choices. So choose whichever one. Do you like angle sum? You like angle difference? I would choose the first one personally. Has smaller numbers. Okay. That's usually a good rule of thumb for me. And now once you get it in this form, you solve this exactly like we solved part A. Okay, so it can be a good idea. If you want some practice, you can do this, or you can find similar problems on the homework. Best of luck. Let me know if you have any questions, and have a good one.